Now that we found ourselves a planet, one question arises. Could it host life? Life, somewhere in the universe, could exist in a completely different form. There could be organisms based entirely on methane, like scientists hope to find on Titan, one of Saturn's moons. Or there could be intelligent beings made of silicon and quartz. The possibilities are endless. As our own Earth is the only planet known so far which does host life, scientists look for some signs which indicate that the exoplanet is in some way similar to our own. It is unlucky that bigger planets, like gas giants or ice worlds, will be suitable candidates. The conditions will be too extreme for life as we know it to develop. Rocky terrestrial exoplanets seem much more reliable for our research. A lot of these planets have been found so far, but what will make them potentially good hosts? The ideal candidate will be found in the habitable or Goldilocks zones. Circular regions around the host star where, based on the planet's orbital distance and the star's temperature, they could present liquid water. Essential for life as we know it. This means that the planet should have a surface temperature between 0 degrees, the freezing point, and 100 degrees when it boils and evaporates. There is no golden rule which tells us how close or how far away a planet should be from its own star to maintain a temperature that is just right. But there are a series of factors to take into consideration. Bigger, hotter stars will allow for much broader habitable zones than their smaller and colder counterparts. It seems logical to look for hotter stars. However, life needs to have enough time to develop, and a star might simply not live long enough for it to happen. As a general rule, we expect the lifespan of stars to depend on its size and therefore on its mass. Luminosity of the star is the amount of energy the star emits per unit time from its surface, which results in its intrinsic brightness. In the core, the continuous, violent nuclear reactions release incredible amounts of energy, which slowly finds its way toward the surface. More massive stars produce a higher amount of energy, so they burn their fuel at a much faster rate than their smaller counterparts. Smaller, less massive stars, on the other hand, live longer, giving a lot of time for life to evolve. They also emit smaller, much safer amounts of UV radiation, as opposed to the extremely dangerous emissions of brighter stars. Another key role in life formation is the atmosphere. The atmosphere, together with the magnetic field, offers a layer of protection against radiation, which is constantly irradiated by the parent star. It also helps to moderate the planet's temperature and supports life by retaining gases that are essential for living organisms, just like oxygen on Earth. However, the atmosphere also needs to be found in perfect amounts. Too much of it could create extremely harsh conditions we see today in Earth's twin planet, Venus. The thick atmosphere is causing a strong runaway greenhouse effect, sufficient to prevent thermal radiation from leaving the planet, causing its surface temperature to increase massively. Despite being found almost within the Sun's habitable zone, the planet is burning. The average surface temperature is about 471 degrees, when without an atmosphere is expected to be about -10 degrees.